Alright, this is lesson 4.3. This is part 2. We're just going to continue where we left off with our graphing here. And so here, if you turn the page, we have a secant graph. And again, don't graph a secant graph. Come over here and graph y equals a cosine graph. And let's just change this slightly. Let's change that problem to a pi half to make it just slightly easier in terms of the numbers. So let's go cosine. Let's go x minus pi halves. And again, we spent so much time with sines and cosines, it's nice to be able to use some of that, some of those facts that we got. And a cosine, remember, we make a chart. We knew the key points for cosine were 0, pi halves, pi, 3 pi halves, 2 pi. It went 1, 0, negative 1, 0, 1, a cosine graph. Okay, how did they alter this cosine graph, or this secant graph, if you want to be specific? They have the x minus pi halves. What does that do to your graph? It shifts it to the right, pi halves. How do you show that on a graph? Well, add pi halves to all your x coordinates. What's pi halves plus pi halves? Pi whole, that's 1 pi. Pi plus pi halves, 1.5. Make that improper is 3 halves. 3 halves and another half is 4 halves, otherwise known as 2 pi. And 2 pi plus a half is 2.5 pi. Make that improper, we get 5 pi halves. So our graph gets shifted to the right, pi halves. So I'll label here, key point, pi halves. Next one, pi, 3 pi halves, 2 pi, 5 pi halves. All right, it's a regular cosine graph. So over here, I think I'll choose my scale here to be 1. Down here it'll be negative 1. And what does a cosine graph look like? Well, it starts at 1 to 0, then negative 1 to 0 to 1. And again, I'm going to use this as my guidelines. So I'm just going to sketch it. Kind of dotted. I'll extend that a little bit. And oh, look. Cosine of x minus pi halves looks a whole lot like the sine of x, because they're the same thing. And again, I'll just keep extending this. Okay, so that's my guide. That is my cosine shifted to the right, pi halves. So I've got those new x coordinates. I know where this graph is 0. I can't take the reciprocal of that. Let's just sketch in these vertical asymptotes. And let's go, did I go purple? Let's go green this time. So we have some vertical asymptotes wherever this graph is 0. That was almost vertical. There's a vertical asymptote. There's a vertical asymptote, somewhere in there. And here's a vertical asymptote. And here's another one. So again, what did we just do? We looked at where our graph was 0. We knew we can't take the reciprocals of 0. So we sketched vertical asymptotes there. And what is my true graph, the one I'm trying to get? What does that look like? That looks like little loops coming off the top and the bottom of our graph. So this is the graph I'm looking for. This is the graph of y equals a secant of x minus pi halves. And again, you could argue that looks a lot like a cosecant graph, and you would be correct. Why does it look like that? Because sine and cosine graphs look very similar depending on their shifts. So similarly, secants and cosecants are going to look the same. So our red graph is our answer. The vertical asymptotes would also be necessary. The dotted, kind of purplish blue cosine graph, that was just a guide to get our true graph. All right, one more of these. And again, we just keep alternating it in ways that hopefully you're familiar with. Here's cosecant of 3x. Want to graph that? Don't. Graph y equals sine of 3x. And again, think through your key points. What does that 3 do? It makes it go 3 times faster. How do you show that? Divide all your x coordinates by 3, or multiply by the reciprocal. Multiply by 1/3. I'll just do that in a different color so we can see it. So take all these times 1/3 times 1/3. Ooh, that'll be a nice one. And I do that, I still get here a 0. Here I get pi over 6. Here I get pi over 3. Here the 3's cancel out, I get pi over 2. And here I get 2 pi over 3. So I have my new x coordinates for my sine graph. And it just shows the sine graph is getting kind of shrunk down here a little bit. I got 0, I've got pi 6 here. I've got pi thirds, pi halves, 2 pi thirds. And again, I had my first key point, which was 0. Amplitude is simply 1. Look over here, there's nothing there, so it's a 1. I'll choose that as my scale, go from -1 to 1. I'll sketch in my sine graph. Goes from 0 to 1 to 0 to -1 to 0. I'll dot that in because that's not really my question. I use that as a guide to answer my question. But the real question wasn't sine, it was cosecant. Let's get the vertical asymptotes again. Vertical asymptotes are where my sine graph is 0 because I can't take the reciprocal of 0. Let's go with those green ones again. So vertical asymptote here and here. Anywhere that sine graph is 0, I'm not allowed to take the reciprocal. It's not possible to take the reciprocal of 0. I've got this. And now let's get our cosecant graph. The loops coming off the bottoms, bounded by these asymptotes. You'll never quite cross the asymptotes. And there we go. So secants, cosecants, hopefully you're finding these very easy if you're good at sines and cosines. And notice even the sines and cosines that we're graphing aren't as difficult as the ones we did in section 2. There might be 1 or 2 things going on, but it would be quite a mean problem to give you all 4 things going on. Vertical shift, phase shift, amplitude change, period change. That'd be quite a problem to do. It could be asked, but generally they back off a little bit when they ask you secant and cosecant questions. So that completes our first 2 videos. That's the first part of the lesson, and hopefully you're feeling very confident with this.